Hello, everybody. Welcome to the webinar today. We have joining us is Josh Christley. He is the laser product manager here at MECCO, and he's here to talk about all things laser today. Before we get started, just a few housekeeping tips. My name is Christina Gleason. I'm with the marketing department here at MECCO. I'll be monitoring any questions that you send in. We'll also have some time set aside at the end of the presentation to go through any questions that you might have. You could also always reach out to us through our website, through LinkedIn. There's a lot of ways to get a hold of us. I'm sure there's a lot of questions out there. So Josh, we are talking about lasers today because there are a lot of people who I know you've talked to who are thinking that, you know, laser should be the way to go for their company, but maybe aren't really sure, you know, what type they need, or some people who maybe just want to improve what they're currently doing. So you've been doing this, talking about lasers, developing lasers, studying lasers for about 2 decades now, with MECCO for about 10 years, so lucky us. So I guess, why do you think it's important that people understand what some of those factors are that go into deciding what the right kind of system is in order to help them better their business?
Yeah, it's very important to understand the technology you're investing in, because if you're just throwing out money for tools and products that you think are helping improve your business and not paying attention to it, you could quickly start hurting your business by not fully understanding what's going on and digging yourself into a hole. So when you're looking to buy that new tool or wrench to do something on your assembly line, you want to make sure you know how it works and how to best use it, and is it even the right tool for what you're trying to do. So we at MECCO like to walk customers and clients through that process and help them understand the technology, understand their process too personally on our side, so we make sure we're giving them the right tool, the right solution to be able to do that work. If you don't, you just end up getting frustrated, upset, and you could be spending a lot of money where you really don't need to. So that's our goal.
Yeah, that's a really good point. Knowledge is definitely power in that area.
Yep.
Great. Well, take it away.
All right. Thank you, Christina, and thank you everyone for joining. It's exciting to be here. I like talking about lasers. It's my life. I like technology and playing and using different pieces of equipment. So it's always exciting for me to talk about what I get to do, because I really do truly love what I do. I also like, and COVID times now, we're not being able to visit or go out, but I also like going out and visiting companies and helping, like we're talking, finding out problems and solving problems for everyone. But for me, it's enjoyable to go on site to your factories and facilities and seeing your processes. I like seeing manufacturing, production lines, and product. It's exciting for me. It's what drives me in this realm too. Also, to really helps me enjoy my job a lot more, is seeing things and helping people. So I appreciate your time and everyone gathering today. So let's jump into it here and maybe start and talk about what we're looking to actually learn today. So what I'm hoping you'll get out of this today is basically three key things. So the basics of laser marking. We're going to talk, high level here. What you should be using to mark, how you should be marking, and then why should you be marking? Why would we use a laser marker? As we're walking through this, we'll talk about popular applications, where it's used, the types of marks, why the heck you would want to do it, why you do certain marks versus the others. We'll walk through some of that. And then we'll talk about the 3 keys for finding the best solution. And we'll walk you through our process, how we get you thinking and how we think on our side to get you the proper tool or development program for you to help solve your issues. So those are some of the key things. As we're going through it, think of any questions. We'll have some time at the end to hopefully answer some questions. So if you have anything, write it down, and I'll be more than willing to answer them at the end. If you don't think of it, if you walk away from the webinar today and say, hey, you know what, I really wanted to ask this question, or you're in a conversation with someone tomorrow and they're talking about it and it triggers something, my email address is on here. Feel free to reach out to Christina, anyone else here. We'll be able to answer your questions. More than happy to educate anyone and everyone on laser technology and how the MECCO experience helps you develop a proper process for your company. So what is laser marking? The simplest way to explain it is just amplifying light to a point that it starts to essentially do a change or do damage to a surface. So if you've ever messed with a magnifying glass in the sun, you can see how you can get at a real fine spot, whether you're playing on a sidewalk with it or trying to light paper on your desk on fire. Seeing that light being focused is exactly what the laser technology is doing. We're pumping essentially light through some optics. We're focusing it down to a spot size. That focused spot and energy is producing heat essentially. That's actually causing a reaction on the material or actually vaporizing material. So the laser is actually doing some pretty cool work. And that spot where it's being focused is really hot. So think of the sun times a really big number, and that's how hot it's getting there. So it's able to melt and make some cool marks. And marks come in many different types and forms. So here's some really quick examples and also types of marks why you would be marking. You start to see it right here. You could see in the left here, this is just a medicine bottle. It's a material that is hard to mark, HDPE. It's white. With our UV laser, you can actually see the little gray squares on there. We can get really nice contrast, and that's a mark that you can't feel. So that's kind of a chemical reaction on the plastic that's permanent. You can see also we can do some color marking versus you can see blue, gold, and black. And this is actually using a green laser. By controlling the contact time, power, and mark speed, you can achieve different essentially heat treating temperatures on that surface of the stainless steel, and you can get certain colors out of it based on that wavelength. So again, that's green demonstrating different control methods of heat treating on that surface and tempering that surface to different colors. In the center is a couple black components, automotive realm, so glass-filled nylons and such, something that sees a lot of heat, could be under the hood. We're replacing a sticker label, where sticker labels obviously can get damaged by water, debris. They could get peeled off, heat, they could curl up and disappear. So what we have here is a demonstration of the laser actually just marking directly on the product, and it's on there permanently. So we have a couple components there. And then on the right, for some fun, I had to make some cup holders. One year, actually Christmas ornaments for my wife. So I cut a tree down in my yard. We cut up the branches, and I used the CO2 laser. It's organic wavelength of 10,600 nanometers. You get a lot of great absorption on organic materials. So with the wood, I was able to put nice marks on there. So you can do from part numbers and useful product information the whole way down to making a cool cup holder with the logo or a custom design on it, just for personalization. So the laser has many forms. It's many tools all in one. It's like the Swiss Army knife. It can do many different things. So as I went through there, I was talking about green, UV, CO2 laser. They're just like different tools in our toolbox. All materials interact and absorb light differently. Certain materials absorb all the wavelength and you don't get a mark. So a really good example here on the left side, again, that medicine bottle with that white natural HDPE, fiber laser won't mark it. You could hit it all day long and it's not going to do anything. At most, you hit it long enough, you produce enough heat, it just melts it, but you're not putting a mark on there. You're just destroying the plastic. So it's very imperative that when you're through the process that we go and we look and see all the tools in our toolbox and make sure we're giving you the proper tool for your application to make sure your process is successful. As we work across the scale here, you can see those pictures on what wavelengths have done those marks, where where it works the best. Not all plastics, for example, on the YAG on the center, the two black automotive parts, the other lasers will mark that, but the best contrast where you get an actual white on black mark, the 1064 nanometer wavelength worked the best for there. So it's something as we walk through the process with you, we'll help you figure out what tool you need, and we'll help package that for your process. So we offer, again, the full spectrum of laser wavelengths and technologies. So we have, this is a real nice splash screen that shows our equipment, ranging from a desktop laser system, which is our newest released item on the left there, the Light Rider. That is our desktop entry-level laser system. Awesome machine, very a value engineered unit. So it starts out right around 19,900, gets you a complete turnkey class 1 laser safe system that you could run, mass production on it if you want. But it's an entry level, so it's only as fast as the operator can load and unload that unit. If you want something more, you want something integrated on your line, or you have line feeding or a robot fed device, it steps into our high-end units, which we call our SmartMark series. Along with the SmartMark series, you get our awesome SmartMark technology, which encapsulates our EtherMark technology. So those lasers will communicate via Ethernet, TCP/IP communication methods. You can connect your PLC directly to it. Rockwell Allen Bradley PLC. We're a Rockwell Allen Bradley partner, so these units will be able to be recognized by the PLC. Add-on instructions and profiles are included. Were developed again in partnership with Rockwell, so it makes those units extremely smart, gets you to the next level beyond the entry-level Light Rider series. And in between, we're offering fiber laser technology. We have direct diode laser technology, which is that Tiburon in the center, the whole way up to the CO2 laser. And in the in-between there, obviously, green and UV. So why would we use laser marking? Why use laser? Obviously, it's permanent and durable. We're directly marking on the parts. So direct part marking is infinitely better than putting a label on something. Even inkjet, the printing can come off, especially with chemicals or UV light will eventually fade labels and inks typically, or based on dirty environment, that label may not survive at all. So it's definitely lasers having the ability to mark directly on something. You have to physically destroy that part, or sand or remove material to get rid of the mark. So it makes it a heck of a lot better for sure than labels. It's also fast. It's high speed. We can mark things as they're going down an assembly line with our mark on the fly technology. We can mark really small resolution. When you're talking some of these optics and lenses, we're down to 25, 30 micron spot sizes as our off-the-shelf basic unit. We can actually tune it and go smaller by using different optical components that's in our wheelhouse of beam expanders and such. So we can do a lot to actually get you a smaller spot size using that technology. So you can get really, really small. And because of that, and if you've seen any of our catalogs or material for marketing, you might have seen our penny, where we've actually marked the Gettysburg Address in a bubble, cartoon bubble right beside Abe Lincoln's head. So it's pretty impressive what the laser can do. And that's not even as small as we can go. That's just a really good handout example of relative size that you can see how small we can do. The other beauty of it is non-contact. There's no fixturing needed, essentially. If you just wanted to quickly mark a tag or a part, especially with the Light Rider, just open the door, throw it under. Our laser software has a preview pointer, which will show you exactly where the mark's at, what it's going to look like. You place it in there, shut the door, make the mark, and done. So no special fixturing, infinitely quicker to do R&D or prototype working. And if you are doing large scale parts one after another, you can utilize a fixture where you're just putting it in and out. Being no contact though, you don't have to worry about, even in the fixturing, holding it down tight or anything like that. So there's a lot of benefits to the non-contact marking principle. Also, minimal consumables. Our laser systems, I would say almost 95% or higher, are all 110 voltage right at the wall. They draw less than a microwave. Even our large units, they're not using a lot of power. There's minimal consumables. There's minimal maintenance involved with them. Essentially, there's an air filter. Most of our units are air cooled, and if they're not air cooled, they're water cooled. So you would have an air filter on the exchanger. That maintenance is just making sure it's clean. The other is just making sure the optic is also clean. If it gets dirty or smudged, you're going to have some absorption of energy, and you'll see your mark decrease. So that's really all there is to these systems to keep them maintained and running smooth, is keeping them cool with the filter and making sure the optics are clean. The wide range of things that you can mark with this technology too. For example, sticker labels might only stick to certain things. Or if you ever bought something in the store and they put a sticker on it and you're trying to get it off and it won't come off, sometimes they're overzealous in that sticker material. But they have to be to get it stuck on there. They want it to stay on there. So you have to, when you're doing labels, you have to have different types of adhesives to be able to stick to different things. One label doesn't really work on everything. With the label technology being limited like that, laser is able to really kick open the doors, because for example, the fiber laser, you can mark on metals, plastic, rubber, CO2, you can get into paper and cardboard. It doesn't matter what it is, it's going to put a mark physically on the part. So the technology, you can really cover a lot of the bases with one wavelength and get really close to marking almost everything. And a lot of your manufacturing houses, fiber is, the bread and butter technology out there. If you're marking metals and such and plastics, fiber laser is able to mark almost all metals and plastics with no issues. So it's exciting piece of technology, and I'm getting excited even talking about it. So as you're putting those marks on those materials, you're getting different reactions. So with plastics, you have essentially 4 key reactions that are going on. One is just a color change, and this can happen naturally, or it can happen with some help. So color change is when the laser is hitting the surface and it's getting absorbed, and you're getting a chemical reaction in there that's changing, and you're getting a different pigment. So you can actually put black on white or white on black, like you saw in some of the early photos. And the mark you can't feel, which is even better because it's like subsurface. This is really nice type of mark, because you can scratch it if you need a subsurface mark. Not all plastics work this way, but certain plastics do. The other realm is maybe you don't want it. Maybe you want it more permanent. Maybe you want it to be felt. There's always that engraved feeling that feels like there's more industrialized or value to it if you can feel the mark on certain parts and pieces. Sometimes when you do a non-surface destroying mark, you don't feel like it could be as permanent, even though it is. Sometimes you maybe want to hit it harder, so you're giving off a different feeling to your product. You can always do engraving, where that mark can be felt and seen that there's depth to it. The other option on certain plastics, how you get contrast, is what's called foaming. What's happening is the laser is being absorbed, the energy's absorbing into the plastic, and as it heats up, it kind of grows like a marshmallow in a microwave. It heats up, there's a lot of oxygen and other things emitting out of it, so it causes it to puff up and foam up. As the laser turns off, it starts to collapse a little bit, but it doesn't collapse to the same scale. Because of the air and other chemicals and fumes being exhausted off into that plastic, you've created bubbles and pockets in it. So actually, you can feel that mark. It's bubbled up. It might have white contrast and look super nice, but it's changed chemically, and what has happened molecularly, that mark itself is totally changed. Right where the lasers hit, that plastic is not the same plastic. So you have this different type of mark, and that's what's yielding another way to do contrast. And the last one here that we're showing it's a really cool application. So in your car, anytime you've hit your window up, window down, or adjusted the HVAC knobs to the correct temperature, all those buttons and switches are laser marked. They're essentially spray painted buttons or painted buttons. The plastic buttons typically clear or white. and they paint them black, and they're backlit so you can see them at night. So the laser, what it's doing is it's tuned to only remove the paint layers. So we're exposing the nice white or clear plastic underneath. So when the light on at night, it backfills it and you can see it as you're driving. So those are some of the cool plastic examples of what you can do with the laser on plastic. Along the same lines, you can do a lot of the same things on metals. So when we're looking at engraving, we're removing material. When we're doing removing layer, we're removing just that layer. So a good example of removing layer would be like anodized aluminum. You have a anodic film to protect the aluminum from oxide. What you can do with the laser is, if it's a color, if the anodized aluminum is blue or black and you laser mark it, you'll typically get that nice bright white finish from beneath, because we're polishing the aluminum underneath and showing it. So that'd be a good example of removing layer. We also have bonding. There's certain materials out there that you can spray on material and use the laser to bond it. One of those out there is like a porcelain paint. I'm sure you've seen it. It's typically on higher end stainless steel stoves and such, where it shows your burner locations and everything. That is a porcelain bonded paint. So the paint is sprayed across that entire surface. The laser process then is heating and bonding the porcelain to the metal. And then you essentially wash the entire surface off with water, and what's left behind is only the bonded area. So that's an example of laser bonding. And then you have carbon migration, which is an example of the earlier photo of the colors, the heat tempering process on materials or metals. As you heat it up, you get different colors. So if you take a chunk of metal, throw it in an oven, heat it up, the hotter you take it, the darker it gets. You can get goldens, blues, purples, all the way up to brown and black as you start to essentially heat treat or case treat that material. That's an example of carbon migration. So, pretty cool stuff so far. All these terms and technologies that we're talking about, you learn through our process. So how we develop and find the solution for you, we essentially 4 easy steps. We like to understand your vision. We like to define your requirements up front. We show you and help you assess the technical feasibility through our lab. We also have whole other teams to help you design your solution, our integration team. And then we, again, another exciting part for us is we like to provide a lifetime service to you. When you buy a MECCO system, you get certain perks for life as long as you have that machine. So one of them real quick would be the applications lab. You would work with an applications engineer through this process to set up your process, find out what equipment you need and how you need to handle those parts and whatnot. You'll still have access to that same group even after you buy the laser. So say something changes in the future, whether it be materials, we will help you walk through, set up a new job file, program the job file differently. You'll always have that access. So that's another benefit of buying MECCO and joining our family, the MECCO family. So to dive in a little bit here, step 1 and step 2, we're gonna jump right into. So as it pertains to me and my group specifically, step 1 is really important. We talk about, hey, materials. What materials are you going to be marking? We like to know how many different parts you're going to be marking. Knowing this helps us size the proper lens that's going to be needed. Because if you're doing maybe a tray of parts, we might not want to use a little lens that only marks one at a time. It might be more beneficial to step up to a larger lens and be able to mark the whole tray if possible with the technology. So that's a key thing to know. The material also, when we know it, helps us define what technology we're marking. Are we marking on wood? Are we marking on metal? That helps us veer down that path to get the correct technology for you. Again, with sizes and dimensions, also plays into how many different parts you're marking. That helps us size that lens. And helps us spec out the proper equipment for the job. Then we jump into, step number 2, the manufacturing process. At what point are you going to be doing the marking? Is this pre or post another step? Maybe you're baking a part, maybe you're painting a part, maybe it's powder coating. We need to know those, obviously, up front and help you think about it too. where it makes sense to go in your line. For example, we don't want to really put a surface etch laser mark and then the very next step be like powder coating or real thick paint. The mark, if it goes through that process, will be totally gone. You won't have any traceability at that point. So it doesn't make sense. It might make sense to mark it after those processes, if possible, or moving the mark in a location that makes more sense. So that's a really key question that we'll dive into through our process here. Also, is the environment clean? Is it, is there dirt, debris? What's even on the parts? How are you handling the parts? Even how do you want your operator to interface with the equipment? Some houses don't want the operator touching too much at all, especially if you're working off of a sheet or trying to type something in. It's sometimes you always have human error, so maybe you don't want the human interaction. So that helps us drive you down the line. Or how are we going to do communication? Maybe we're going to do the Smart Mark series to be able to get you the network capabilities that system offers. So those are things, again, we're going to help you through it. And then what are your efficiency goals? Obviously, through our testing, we're going to figure out the mark time. We don't want you to fall into trap though to think that's the entire time. We'll also work through and say, hey, that is the mark time, but we need your total accumulated time or tack time that you're envisioning the process to work through. And knowing that also, or working that out with you, could drive us to a more powerful laser to be able to drive down the cycle time to be able to fall on the overall tack time that you're wanting to hit. And a lot of these things we're working through today, Christina will have at the end, we'll have a sheet that actually has a lot of these keywords and examples of the process that we'll be able to share with you too. And we'll get it for you so you can review it and see how our process works out. So once we've had these discussions, we've worked it out, we know where we're going with the product, what we're doing, it's time to design the solution. This is the fun part. So we have our integrations group who are going to sit down with you and they're going to discuss, hey, how do we get everything you need packaged now? We know the equipment that needs to make the mark. We know how you're part handling it. We know the volume that's going on and how much time we have to do it. The next is packaging it, making it nice and making it fit your needs. So this group is going to obviously want to know, the exact data you're marking, where it's coming from, how you plan on communicating from. Do we need to write a custom graphical user interface, or we can use something off our shelf to do the communicating back and forth? Do you require vision? Do we need to work in a Cognex camera, a Keyence camera? What do we need to do to get you, post-mark certification? How do we determine what's a good mark versus a bad mark? All this will come in play during the integration step. Again, that group, they do this day in, day out. They've come up with some pretty awesome machines, amazing machines to solve people's needs. So that's step 3. And then once we get through and we're all happy and everyone's got a machine on the floor and everything's great, things break. We get that. There's nothing perfect in this world. Just like this webinar, I'm sure I've made several mistakes and stuttered around. No one's perfect. We're humble. We realize that. What happens though when it hits the fan? What do we do? And that's where MECCO steps in, and this is where we excel. We like to say you're joining the MECCO family. We don't sell a machine. We look to partner with you. So we're offering the Mecca Experience. You're getting live support. You're getting, 2-hour guaranteed response time for talking to someone. You get 2-year equipment warranty on our Smart Mark series lines. Again, that free sample marking, your material changes or something's going on, you're having issue. That's always free through our applications lab. That initial marking setup, say you get a new part in, you need help setting up a new job file. Again, that is covered. That will always be free through us. It'll be sent in. You could send us, email us a job file. We can even remotely log into your systems. All of our systems come with a TeamViewer account. It allows us to see your screen. So you could call us up, let us know. We can log in. We can see the screen. We can walk you through it. And we can help you set up for success in the future. We'll continue that communication through account reviews. We could do regular reviews, ask what your challenges are, what you're looking to progress, and we want to get success between both of us. We want to make sure this is a win-win for both sides, and we'd love to be involved, and we love helping. Again, it's a partnership, and we look forward to partnering and welcoming everyone into the MECCO family. So, top 3 takeaways from the beginning, what we talked about here. Hopefully everyone, this is all sitting, there's no test, so what hopefully sat well is, we strive for understanding what laser marking is. Hopefully you've understood how it works, why it's important to use laser marking. Hopefully also the key elements to scope your solution, you've taken note, and this reverberates on you, is what's important is your materials, your manufacturing process, how you want it to happen. We don't want to just sell you a machine that we think works for you. We want it to work for you based on what you're asking for. And then an idea of how you want to integrate it. We're going to be there through the entire process for you. There's always a lot of variables. So anytime you have questions, we're always here to be able to talk to us, use us. We are the experts, and we're always here, again, for free test marking, new materials. Let us know. Not only are we helping you in developing a profile or a setup, you're also helping us grow too as a company. Seeing your material and understanding what's going on and learning more is also growing our knowledge in-house too. So again, it is a mutual relationship, and that's what we look for with working with you guys. So I can welcome Christina back, and we can jump into, does anyone have any questions?
All right, I just saw something pop up here. So we have, what's the highest temperature that you can mark aluminum? Can you do it with the metal at 900 to 1200 degrees Fahrenheit?
Yeah, so that temperature sounds hot, right? But the laser beam itself is infinitely hotter at the spot source, so it can mark it. The things, though, that have to come into play is when you're marking an environment that hot is, where is that laser? So if that hot part is underneath the laser, we have to make sure that that laser is cooled, because heat is obviously radiating up. Any electrical wiring is going to have to be shielded. So we have done some hot marks. I don't know offhand if we can actually do 9 to 1200. Again, we'd have to talk to the integrations team. But these are the questions we're going to have back, is orientation, what's going on. The laser itself, yeah, it's going to mark it. You do have to be careful, though, because as things are still hot, that metal is still metallurgically changing. So if we put a mark on there, it might become less readable as metal cools and contracts. So if we're etching or such on there and it comes out maybe light because the metal's still red hot, when it cools and contracts, since it was hotter, that mark could get really, really, really dark as it cools. Depending on the material too, if it wasn't aluminum, let's say it's steel, you actually start growing iron oxide on it. So you could be creating a super dark, crusty mark on there. So those are things that we would work through in the lab and try to figure out and solve for you.
Wow. All right, we have another one here. What is the maximum depth of part topography that can be marked? Example, a curved surface.
Yeah. So curved surfaces, and we have a laser beam coming down. So it would be cool if we could just wrap the whole way around there. That is 3-axis technology. That is something that is coming along in our wheelhouse, but it hasn't been hot coming along, because in almost all of our applications, we found that you don't really need it. It is nice for a lot of artistic marks and such. Maybe you're marking on a mouse pad where you have flowing geometry, but if you're marking just on a radius part, really don't need the 3-axis technology. What you need to do is utilize the lens and the lens's ability to be able to do this mark. So the beam is coming out of the lens itself, and it's coming down through, and it's going through, essentially looks like an hourglass. So at your cross, your waist, the midsection of that hourglass, that's where the laser makes its smallest spot size. If we focus that on the surface, we can make a great mark. As we go off the edge, the spot though starts to grow, and we're not able to do that. So we need to pay attention to what's called depth of focus. So we look and we have all this data. You could actually tell us the radius and we could tell you how much you can mark around. But in generalities, every lens has what's called a depth of focus. Our focus and where we set our zero on all of our equipment is to the center of that. So you actually have a plus or minus value. So when we're going around a curve like that, we set it to the highest point in that depth of focus. So now we have the curvature coming up and just touching the top and coming down. So this segment, as long as your geometry falls within the depth of focus, we can mark the whole way around that area. So it's definitely doable. And from the larger the lens you go, the deeper that depth of focus is, and the larger the part that you can fit in that depth of focus.
Right. Well, to that point, John asked, is it possible to measure the depth of a laser mark?
Yes, for sure. As you're removing material, it's just like chiseling. It's just like a dot peen mark. You can do it with a drop gauge. Depending on how small the mark is itself, your pin may not be able to get in there. We can use in our lab, you can use a line scanner, a 2D line scanner, which is a laser. It's tracing across it, and that'll build a 3D model, which we can get those values from. So yeah, it is possible to do that.
Okay, I have one more question here, and then I also have a hand raised. So Pete, I'll get to you in 1 second. Another question here from, oh, Pete, you sent yours in too. Here, Greg had sent his in before. Are there any safety issues or concerns that need to be considered?
Yeah, definitely. So if you're buying, and what we had discussed earlier, that LightRider desktop unit, that is a turnkey class 1 laser safe. There's no concerns on that thing. You can walk up to it. It's designed, shipped from us, good to go. All of our custom systems are also designed in that manner. They're already coming laser safe. The only thing where you have to be concerned about laser safety would be our OEM units, and your concern would be how you integrate it. So if you come to us with an application, say you're buying an OEM unit, you're just buying laser, we would help walk you through what you need to make it laser safe and how you're using it. So we would ask to look at your line, where it's being mounted, the locations, and we'll tell you how to enclose it and walk you through what you need to know. But definitely you have to consider laser safety because, for example, the fiber laser, the CO2 laser, you can't see those beams. And that's the thing. What you can't see is what's going to hurt you. The spark and flashing is not the laser beam. That's not the wavelength. That's an interaction with the metal. So it's just like a water flash. What's hurting you is what you can't see. Green and UV laser, you could see it. So you know if you didn't do laser safety, it's going to light up the room like a flashlight. So the invisible stuff is just as dangerous, and you definitely have to be aware of it.
For sure. All right, so Pete's question was, what is the laser source used in your LightRider, fiber or direct diode? What power and wavelength options are available, and what mark fields do you offer? So a few questions wrapped up in there.
Yeah, so the LightRider series is our fiber laser. It is 20 watts. It is a value engineered system, so there's not a lot of options on lenses. We offer the 160 and 254. So it goes from 4-inch square field roughly to a 7-inch square field it can handle inside it. 20-watt fiber, so it's 1064 nanometer wavelength. Did I miss one of those questions there? Maybe, possibly.
Power and wavelength options available. What mark fields do you offer?
Yeah, 4 and 7-inch. The OEM version of it, though, because we do sell it as if you want to integrate it yourself. Again, it doesn't have all the bells and whistles of the Smart Mark, but it's still the same fiber technology. So if you don't need all the bells and whistles in your communication and you're just running a job over and over again, the LightRider does make sense. And we offer the same lenses that we offer on our higher end. So you can do 4-inch up to like a 13-inch field, I do believe.
All right. Where is MECCO and where are your lasers manufactured?
Awesome question. MECCO's home base is in Cranberry Township, Pennsylvania. We're 45 minutes north of Pittsburgh in Pennsylvania. We build everything and fabricate everything locally here. We also have our own software. So the Winlay software is MECCO owned. Same with the control card, the circuit boards that control everything. That is in our Acton, Massachusetts facility, and that's where our boards are developed and software is written. Also, a lot of our custom GUIs are coming from up there. The lasers themselves, like I said, we are laser experts. Not only do we build everything and use varying components from other suppliers, we also build our own laser systems. So the direct diode laser, the Tiburon laser, is a built machine by MECCO. We do it in a clean room, optics, gain medium, the whole 9 yards, direct diode pumping, all the testing. That machine itself, that laser is a tank in how it's designed and built. We're really proud of it. So we know lasers, we know how to integrate, and we only partner with the best components out there to build our equipment.
All right, I apologize. There's some noise in the background here. Working from home. We have one more question, or no, 2 more questions here. I'm sorry. Can you put a UV into the light writer?
That's a tricky question. So the light writer is what we call our light writer is a desktop standard unit. It only accepts what it accepts. We build custom machines though. So it is possible we could look at taking that machine and putting a UV laser in it, but at that point it becomes a custom integrated solution. So it would not be referred to as a light writer. It may all well be look exactly like it though, but that would be something that's not currently offered. So that would be a custom request, and it would go directly through our custom integrations group for sure. But yeah, we can integrate a UV laser in any manner, shape, or form. That's part of our design, form, fit, and function process that we'll go through with you.
Right, and I have one more here. The SmartMark has the AB communication, correct? Ethernet IP.
Correct. We're Allen Bradley partner. So our Ethernet technology, when we brought it out, we caught their attention. They actually approached us and invited us to join the partnership. That's how we got onto the Rockwell Allen Bradley partner program, and they helped us and made it even easier by developing the add-on instructions and add-on profiles. So yeah, it essentially makes our laser system plug and play with Allen Bradley products. So that is super exciting.
That is. Well, oh, another question just popped up. Will you be doing a webinar on Safety Seal?
That's a great question. Are we?
I think we should.
Sounds like it.
Yeah, thanks for the recommendation, Scott. Yeah, I guess, do you, Scott, do you have any specific questions on the Safety Seal now that we can address? Give him a second in case he, or you could also raise your hand and I can unmute you if you want to talk with Josh right now. Sorry about that, Scott. I'll get to you in 1 second. All right, go ahead, Scott.
Yeah, I just want to get a better understanding of Safety Seal, how it all works. I've got several customers that are looking at it right now, but they have questions, how of a variance can a part have when a Safety Seal comes in? You know, some are plastic parts, some are metal parts, things like that.
Yeah, great question. I'm not the safety seal expert. Our integrations group would be, but your questions are I can answer these. So um, the safety seal mechanism, the sealing mechanism, and just to back up so everyone's aware of what a safety seal is. So it's our patented technology. No one else in the industry has this. We have our laser rail, essentially, and then where the lens is, we have it encapsulated and enclosed. And there's what we call a snorkel that comes down. It drives down, it's pneumatically driven, and it seals on the surface like an octopus would. It grabs on and it seals that surface, so the laser is going to mark in that cavity. That system is CDRH certified as class 1, so you can work beside it and everything else. And it makes it very nice because you can mount it on a robot, put it on a slide, just leave it in place and have it actuate on the line. So Scott, yeah, your questions are, you know, how do we make it work for essentially everything? Is the end effector of that snorkel can be modified. So we do round parts, and we actually make the mold of the rubberized seal. I call it a gummy bear because it feels like a gummy bear, but that seal on the bottom, we can change that. We will change radiuses. We can make it fit. Maybe you're doing several products. We can make that effector interchangeable, that you could swap in and out and do several different products with it. Again, that's all part of working with the integrations group on your process and explaining to them and giving them drawings and models, and they will make it work, that end effector seal and work on there.
Okay, appreciate it. But it'd be nice if you had a webinar on it. That way my customers could attend it as well and learn about it.
Yeah, I think it's a smart move. I think we should do that because it has changed. We've added a lot of features and functionality to it. It would be good if we got the integrations group together and even communications group. Pat could probably do a little section of it too to discuss integrating it in the best ways.
All right, thanks.
Yeah, thanks for your
Thank you.
question, Scott. Yeah, we can even try to reach out to you afterwards, one-on-one, to see if we can answer any questions for you or what we could do to help you out. So Josh, there's another question here from John. Do you have any data regarding the depth capabilities relative to material type, hardness, and cycle time?
A lot of the times we do. So quick answer, yes. We don't really release that information because everyone's material is essentially different. Generalized materials, yeah, we could do a real quick study, because if you're talking like 6061 aluminum or 316 stainless steel, something like that, that's common, that's something we could provide. If you have an exotic material, something different, we definitely want to hit it in the lab for sure to make sure we're getting the proper results. But yeah, we do know material removal values for those. And you're limited based on the lens also. So if you remember to my comment about the marking on a curvature, you're using that depth of focus. The same applies for material. You cannot engrave any deeper than that depth of focus, because that's where the beam's at its smallest point, and that's where the material and energy removal is happening. So it's based on your lens, based on your application. So we'd have to know a couple other questions of what are you marking? Are you marking one at a time? Then to increase material removal, we'd probably go to a smaller lens, so we have more energy, smaller spot size to increase it. So there's a few things. Again, that's step one. Step two in our process in the lab is fleshing that out with you, and yeah, we'll be able to provide you material removal after that.
That's so interesting. You really are the laser expert, Josh, and I love how passionate you are about the subject. Yeah, if we don't have any more questions for today, Josh did mention the worksheet that we have created that kind of walks you through that process with kind of those three key factors: the materials, the manufacturing process, and the integration, and kind of those questions to go through and ask yourself as you can kind of scope out a potential laser project for yourself. Or like I said, you could always get in contact with us. So that is posted to our LinkedIn page right now, so you can go ahead and download that. We want to thank you so much for your time and your thoughtful questions today. And we look forward to seeing you at our next webinar, maybe Safety Seal. So thank you guys very much and have a great day.